different look at problem solving. We are going to be transforming formulas. What that means is that you are going to practice taking a formula and solving it for a variable. So I'll show you what I mean. If it says, first of all, solve for the given variable, and it may say it just like that, solve for the given variable, or it might actually say the letter, solve for x, solve for n, whatever the variable is. What that means when it says solve for the given variable, or actually gives a letter, what this means is get that variable by itself. You are not going to be solving and getting an actual number answer for these. So solving in this case, that's not what it means. Solve for the variable means to get that variable all by itself. You will still have other variables on the other side of the formula. So for example, if I said S equals 2 pi r h. Now for the most part, you don't need to worry about what these formulas are for. This one is for something to do with a sphere, I believe. This is geometry, a geometry formula. Pi, right, is the symbol. Think of pi in these problems like a variable. You're not going to substitute 3.14. You're just going to leave it as the symbol, just as we have other letters as the symbol. And then what it's going to do in some cases is you'll have a little semicolon, or sometimes they do a comma. Let me see if I can see. No, I think they're going to use a semicolon. I take that back. And then what you're going to see in your book actually with your problems is they're actually doing it in blue. So in this example, I'll put the H. What this means, the way the book is showing it, is this is the variable you're going to solve for. So the semicolon shows the end of the equation or the formula. And then the variable that comes after it is the variable that you are solving for. Now, again, solving means getting it by itself. So what we're going to need to do on this formula is try to get the h by itself. Think about this title. Transforming means undoing by doing the opposite operation. So in this one, we've only got one operation happening amongst all these. What operation is happening over here with the h? CJ? Good. It is all being multiplied. Because these are all being multiplied by h, if I want to get h by itself, I'm going to do the opposite of multiplication, which is division. Now again, because all of these three items, 2, pi, and r, are all being multiplied, I can do it all at once. I'm going to show you an example in a minute where you can't do it all at once, but this is a simple one to get us started. If I divide by 2 pi r on the right side, I have to divide by 2 pi r on the left side. These all cancel each other out. Technically, they each equal 1. 1 times 1 times 1 times h is just 1h. And I have it by itself. We have solved for h. That's all it means. You're not going to find out what h equals in a number form. You're still going to have these variables. Okay, so that one was pretty simple because we could do all the operations together at once. So let's do one that's a little bit different than that. Area, this would be, by the way, surface area, but you don't need to know that, equals s squared plus 2rs, semicolon shows us we're at the end of the formula, and we're going to solve for r. So this one's a little more complicated because it's not just a bunch of stuff being multiplied by r. We've got an addition here. We've got some multiplication happening. So if I want to get r by itself, think about what I would tell you on a regular equation. If there's more than one operation alone, I'm always going to say, leave the variable alone. And in this case, I'm talking about the variable that we're trying to get to, the r. Leave the r alone and undo the other stuff first. In this case, the other stuff is adding s squared. How do I undo adding s squared? I subtract s squared on both sides. So on the right side, s squared minus s squared goes away, leaving 2rs. On the left side, the a has to come first. It was there first. A minus s squared, because in subtraction, remember the order makes a difference. So again, if there's more than one operation, leave the variable that you're trying to get alone, leave that alone to start, undo the other stuff first. Now we can come back. Now it's like the last one. I just have multiplication. I can divide one at a time, or if I want to, I can divide both 2 and s at the same time. 2 divided by 2, s divided by s, they cancel out. Technically they equal 1, but 1 times r is just r, so we can just cancel them out. And now I've got a minus s squared all divided by 2s. And in this one, it is important that we subtract the s squared first, because then by the time we divide by 2s, we're dividing the whole left side, not just one piece. The whole thing gets divided. Any questions on that one? Okay, not too hard, I hope. Let's do one more. Last example. Let me find, where's the one I wanted to do? I'm just going to try to find another one with multiple operations. Okay, let's say A, we're going to get the t by itself. A equals v minus u divided by t, and the t is the one we want to get by itself. This one's even slightly different a little bit. This one's different because this is a binomial divided by t. The first thing I can do here, the only thing I can do to start, is to undo divided by t. The only thing I can do, again, is to undo, to start, divided by t. To undo divided by t, I would do times t on both sides. Now on the right side, they cancel out. T in the numerator, t in the denominator. On the left side, I'm going to leave it like that. I'm not going to push them together yet because I don't want to keep them together. I want to get the t by itself. So notice it didn't look like it was going to help us to get t by itself when we started by moving the t. Normally we want to start with all the other variables, but in this case there's nothing I can do here until I get rid of the denominator. Now I'm very close to getting t by itself. Now there's only one step left. T is being multiplied by a, so I will do the opposite. Now again, notice that for a lot of this division, I'm showing it as a fraction bar. I'm going to suggest that you do it that way as well. Because if you don't, let me just show you on this problem. If you had back here, and you can just watch on this part if you like, if we were back at this step, and you wanted to, whoops, I'm sorry, it was like this. If you were going to divide by a, and then you just write divide by a, they cancel out, but look at what's here. If you just stick on the divide by a at the end, according to PEMDAS, what would I do first? Vincent. I would only do u divided by a. But what this is the entire thing is being divided by a. It's much easier to show that by just doing division as a fraction bar. If you use the sign on this one, you would have to have parentheses, otherwise it's wrong. Okay? So I'm going to suggest that if you are dividing for any of these problems, that you divide by showing a fraction bar. If you do it that way, you don't have to worry about it. You're just dividing the whole thing by a. Otherwise, to divide the whole thing by a, you would need parentheses. So just be careful on the division problems. That's it for today. So your homework from page 166. Now in the directions, guys, this is written exercises. In the directions, it says says something about stating the restrictions. Ignore that. You don't need to state the restrictions. We haven't talked about what it means. I don't need you to do it. So all you're doing is solving for the variable that's shown in blue. That's it. Okay?